Welcome to Astronomy Daily,
the podcast where we break down the biggest news in space and astronomy. I'm Avery.
And I'm Anna. We've got a great show for you today. We'll be looking at a major milestone for Rocket Lab's new reusable rocket taking shape in Virginia. And get this, the James Webb Space Telescope has found a truly bizarre planet-forming disk that could rewrite our understanding of how rocky worlds are born.
And plus, we'll dive into the explosive solution to the mystery of hypervelocity white dwarfs. Stellar cannonballs getting ejected from our galaxy.
And finally, a poignant story about a piece of space history, recovered from tragedy, now being auctioned for a very good cause. So stick around. All right, let's kick things off on the East Coast of the U.S. It sounds like Rocket Lab is making some serious moves.
That's right. They just held a ceremony to inaugurate their new Launch Complex 3 at Wallops Island, Virginia. And this isn't just another pad for their trusty little Electron rocket. This is the new home for their much bigger next-generation Neutron rocket.
Neutron is a significant step up for them, isn't it? It moves them squarely into the medium-lift launch category.
Exactly. While Electron is a fantastic vehicle for small satellites, Neutron is an absolute beast in comparison. It's designed to lift serious payloads, about 13,000 kilograms to low Earth orbit. That puts it in competition with some of the real workhorse rockets flying today.
And the whole facility is built for speed too. I read that the pad is specifically designed to support a high launch cadence.
It is, but the rocket itself is where the innovation really shines. It stands 141 feet tall, but its most unique feature has to be what they've nicknamed the Hungry Hippo fairing.
That's a fantastic name. Let me guess. Instead of the payload fairing just jettisoning and falling into the ocean, it's actually part of the first stage and is reusable.
You nailed it. The fairing opens up like a giant mouth to release the second stage and the payload, and then it closes right back up before the entire first stage returns to Earth for a landing. It's a really clever approach to making the whole system rapidly reusable.
That really streamlines the whole process. So when can we expect to see Neutron take flight?
They're targeting the maiden flight for the end of 2025. It's certainly an ambitious timeline, but Rocket Lab has a habit of meeting its goals. And this isn't just good news for space enthusiasts. The project is also expected to create over 250 jobs in the region.
It's a fantastic development for the commercial space industry. It's very exciting to see another major player making such big strides in the reusable rocket game.
Well, from new rockets getting ready to fly, let's turn to new discoveries from orbit. The James Webb Space Telescope has once again delivered some truly mind-bending science. This next story challenges some of the core ideas we have about how planets like our own are formed.
It really does. JWST was pointed at a protoplanetary disk. That's the vast swirling cloud of gas and dust around a young star where planets are born. This particular one surrounds an infant star named XUE-10, which is located about 5,500 light years away.
And what did it find that was so out of the ordinary?
It found that the inner part of the disk, the exact region where we'd expect to see rocky, Earth-like planets forming, has a very high concentration of carbon dioxide. But what's really striking is what seems to be missing: water. The telescope found a surprisingly low amount of water vapor in this critical zone.
That seems completely backward, doesn't it? Our current models of planet formation suggest that this inner region should be rich in water, which we consider a key ingredient for the development of life. It throws a bit of a wrench in the works. Scientists are now scrambling to figure out why this particular disk is so water poor and carbon rich. One of the leading hypotheses is that the entire star system is being blasted by intense ultraviolet radiation from massive hot stars nearby.
So that intense radiation could literally be changing the disk's chemistry, perhaps breaking down the water molecules or preventing them from settling in that inner planet-forming region?
It could be altering it completely. And this discovery isn't just about a strange, distant star system. It might also help explain some unusual isotope signatures that have been found in meteorites right here in our own solar system. It suggests that the chemical makeup of our cosmic neighborhood during its formation might have been very different than we previously thought.
Incredible. So the recipe for making an Earth might be much more varied than we assumed. It's just amazing how a single observation from Webb can open up so many profound new questions.
From making planets to, well, breaking stars. For years, astronomers have tracked these truly bizarre objects called hypervelocity white dwarfs. Now, a white dwarf is the super dense remnant of a sun-like star, but these ones are moving so fast that they're on a trajectory to completely escape the Milky Way galaxy.
Right, they're like stellar cannonballs. The fundamental question has always been, what kind of cosmic event could possibly launch an entire star with that much force?
Well, a new study using some powerful computer simulations believes it has the answer, and it is incredibly violent. The leading model is being called the D6 scenario, and it all starts with a binary system of two white dwarfs orbiting each other in a tight embrace.
A stellar dance of death, I imagine. What happens next?
The lighter of the two stars gets gravitationally shredded by its heavier companion. Material from that disrupted star then forms a layer of helium on the surface of the more massive one. This accretion is what triggers a cataclysmic two-stage explosion.
2 stages? How does that work?
First, that outer shell of helium ignites in a massive detonation. This explosion sends a powerful shockwave inwards, compressing the carbon-oxygen core of the primary star. And that shockwave is so unbelievably intense that it triggers a second, even more powerful explosion. A full-blown Type 1a supernova.
And that supernova completely obliterates the primary star.
It's utterly destroyed. But the companion star, the one that was initially torn apart, actually survives the blast. The sheer asymmetric force of its partner's demise is what acts like a cannon, flinging it outwards at these incredible galaxy-escaping speeds.
Wow, so one star is annihilated just to launch its partner across the cosmos. The simulations must have been phenomenally detailed to pinpoint that mechanism.
They were. The D6 model successfully recreated the incredible speeds and physical properties we observe in these hypervelocity white dwarfs. It's a major breakthrough that not only solves the stellar cannonball mystery, but also gives us a clearer picture of one of the ways Type 1a supernovae can happen. And those explosions are crucial cosmic yardsticks for measuring the expansion of the universe.
For our final story today, we come back to Earth to remember a tragic but incredibly important moment in spaceflight history. A very unique set of artifacts is going up for auction. A dozen Sacagawea dollar coins that flew on the final mission of the Space Shuttle Columbia, STS-107.
This is such a powerful and moving story. These coins were originally part of the U.S. Mint's Coins in Space program. They were meant to be put on display at places like the Smithsonian after the mission. But of course, the Columbia tragedy occurred during re-entry in February of 2003.
The shuttle was lost, along with its 7-member crew. It's honestly hard to believe that anything, especially something as small as a coin, could have survived that event.
It is, but during the massive debris recovery effort across East Texas, these coins were found. They were charred and damaged from the intense heat of re-entry, but they were recovered.
That's amazing. But how could they be absolutely certain that these were the authentic coins that actually flew on the mission?
This is the incredible part of the story. The U.S. Mint had kept control coins from the exact same batch that never left the ground. Forensic investigators were able to compare the unique metallurgical properties of the recovered damaged coins to the pristine control set. And they confirmed they were the genuine articles.
And now, after all these years, they're being auctioned by Heritage Auctions.
Yes, and for a wonderful cause. The proceeds from the auction are going to benefit the Astronaut Memorial Foundation and other space-related charities, all dedicated to honoring the memory of fallen astronauts.
It's a truly powerful way to remember the crew of STS-107. These coins aren't just currency, they're a testament to survival, to the memory of the crew, and to the enduring spirit of exploration. A truly poignant piece of space history.
And that's all the time we have for today on Astronomy Daily. From new rockets preparing for flight to deep mysteries of planet formation and violent stellar explosion.
And a humbling reminder of the human side of our journey into space. It's been another fascinating day in the cosmos.
Thanks so much for tuning in. We'll be back next time with another roundup of the latest space and astronomy news.
Until then, keep looking up.